work on this question. It's for 2016 MT1 question 3.3. The question is as follows. You are given two signals, multiply them together, integration. The question is what's the final answer? Is the question clear to everybody? The way we solve it is we just plug it in. So therefore you get negative 2 pi over omega, 2 pi over omega. If you plug it in, you get what? Ej2 omega t times Ej3 omega t dt, which gives you omega 2 pi omega Ej5 omega t. The question is, how do we proceed? The way we proceed is we just follow basic integration. So you get J5 omega Ej5 omega times 2 pi over omega minus Ej5 omega times negative 2 pi. So basically the same as before. Integration, the upper limit, lower limit. And if you do it right, you get J5 omega. Now you get what? Ej 10 pi minus Ej negative 10 pi. So the question is, what is this value? The answer is it's 0, because Ej 10 pi, what does that mean? If you look at the real and the imaginary part, Ej 10 pi meaning I'm circling it 5 times. I'm circling it 5 times, and I'm going to land at 1. So therefore this equals to what? Ej 10 pi circling 5 times, landing at 1. E negative j 10 pi is I'm circling it, but in a clockwise fashion. And then again, I'm landing at 1. So 1 minus 1 is going to be 0. That is how we got the final answer. But if you go a little bit over, you can actually tell that it's going to be 0 from the very beginning, because you can see whenever the difference of this is what? 4 pi over omega. The difference of this is 4 pi over omega. If I plug in 4 pi over omega, you can see that gives me what? 8 pi. For 8 pi is already repeating itself. Here it's Ej3 omega t. It's also repeating itself. Therefore, it says that you have cosine and sine. I'm integrating over integer number of 2 pi. It's going to give me 0, right? Because cosine, if you look at cosine, you can see for one period, this cancels the other side, right? This positive cancels the negative. Therefore, this is cosine and sine integration over a period or multiple periods will give you 0. That's basically what it is. If I answer your question, everybody is okay with the solution? Let's move on. Jonathan.